Alright, so we're going to start off chapter 10 now, and you can read, but some things to highlight. A polynomial is an expression with constants, variables, and exponents, which are combined using only addition, subtraction, multiplication, but not division. Okay, so these expressions are not combined by division. The exponents can only be 0 through 3, or 0, 1, 2, 3, etc., meaning all the whole numbers, no fractions, no decimals, and cannot have an infinite number of terms. We also define like terms as terms whose variables and their exponents are the same. In addition and subtraction, only like terms can be combined. So let's look at this example. So 4x squared y cubed plus 16x cubed y. We'll notice this y is y to the first, plus 8x to the first y to the second, plus x squared plus 71. So the coefficient of the nth monomial, meaning the first, the second, the third, the fourth, the fifth, so the coefficient is the number that is in front. It doesn't always have to be in front, and in fact this 8 is not the coefficient. Negative 8 is the coefficient. You'll notice there's no coefficient here, so it's always 1. And you could argue there's no coefficient here, or you could argue that 71 is the coefficient to x to the 0. Because x to the 0 is just 1, so 1 times 71 is 1. That's not really going to be an important factor, but it could be 71, or you could argue that there is no coefficient. So those are these values that were listed right here. And now the degree is the combination of the addition of the exponents of the variables. Now the degree often dictates what the function will look like graphically, and so that's why it's important to know the degree of the function. So you'll notice here 2 and 3, 2 plus 3 is 5. 3 plus 1 is 4. Most people make a mistake there of just putting that as 3. 1 plus 2 is 3. 2 is just the next one. You'll notice there's no x to the first term, and then 0 here because it's x to the 0. So that's the example, and so we'll go through each of these quickly. You'll also notice that this highlights the degree of the polynomial is 5 because that is the largest degree of a monomial. You'll notice the first one is a 5th degree. So that is the degree of the whole polynomial, not just of the first term, but of the whole thing. The number of terms, there's 5 terms. 1, 2, 3, 4, 5. And the leading coefficient is the coefficient of the largest degree monomial. Since this is the one with the 5, the coefficient to it is 4. So that's the leading coefficient. The leading coefficient isn't a counting thing, it's the number that is in front of that monomial. Now we're saying monomial. Monomial just means a single term polynomial. Okay, so this monomial, 6x cubed, the degree is the combination of all the exponents of the variables, which is 3. Number of terms is 1. The leading coefficient is 6. The degree of this one, there's 3 in the first term, 2 in the second, and 1 in the third, so the biggest one is 3. The number of terms is 3, because 1, 2, 3 things separated by pluses and minuses. The leading coefficient is 2. So again, not the biggest coefficient, but the coefficient of the highest degree term. Here we have x to the 6th. The degree is 6, because that's the biggest exponent. 2 terms, and the leading coefficient is 1, because you don't have anything in front of an x to the 6th. It's just 1x to the 6th. This is 7 for the largest exponent. Number of terms is 3, because there are 3 things separated by pluses and minuses, and 2 is the coefficient of the x to the 7th. The degree of this one, again, we think of this as x to the 0, so this is a 0th degree polynomial with 1 term, and leading coefficient you could either write as 0 or 1, 5, 3, 2. I would say it's this. But other math teachers have argued otherwise. And then this, it's kind of hard to see because you have a multiplication problem. So in order to really figure out the degree of the polynomial, we need to distribute. So this is 5x to the 4th minus 5x cubed plus 25x, and that's where I evaluate. So this is 4, because that's the largest exponent, 3 terms with 5 as the leading coefficient. So write an expression that is not classified as a polynomial. Well, if you go back and look at the rules, you can't use division, and the exponents can't be non-integers. So you could say, for example, x to the negative 1/2, or 3x to the 0.2, or 1 over x to, like that. These are all non-polynomial expressions. So that's that. So the big idea here, just a few set of terms that we need to know because we're going to refer to. The coefficient is the number in front. The degree of a monomial is just the sum of the exponents, and the degree of the polynomial is the largest degree when you look at all the terms. The number of terms is just the number of items separated by addition or subtraction. And I think that's about it.